Okay, so I'm going to take a previously used design for this demonstration. So I'm going to go File, Open, and let's see if we can find my file. Okay, so in this example, you can see this file here. We have blue is the copper, and then we have this kind of mustard color around the copper trace, which represents isolation. So let's go over how we actually make those isolation traces. So I'm going to go to the layers and delete all the previous layers so we can have a good example here. I'm going to save this as a new file. Okay. So the first thing we typically do for the circuit board is drill it. And that's because if we have a double-sided board, we are planning on having a chemical process to electroplate the actual holes that we drill. And that connects the top copper to the bottom copper. But in order for that system to work, we have to have a complete piece of copper at the top and a complete piece of copper at the bottom in order to conduct energy through all those holes. So the first thing we're going to do is drilling, which is really a simple operation. So let me just check that I have all the tooling that I need. So I'm going to go to the Tools section, and then I'm going to the drill file that actually represents all the drill holes in this particular model. Now the 42 mil drill bit that's necessary, 18 mil drill bit, now the 13 and 10 mil drill bit. So what I did previously is I modified all the drill holes to use the tooling that we have. So we have the 18 mil drill, and we have a 42 mil drill. So I'm going to basically just use those holes. And to the right, we have the tool pod, which indicates what kind of tools are currently in the tool pod that the machine can automatically change between. So let's see that in number 3, we have an 18 mil drill bit. We have a 42 mil drill bit. If you want to add your own drill bits later, this tool table is where you would enter information for it. And these RPM, feed per minute, depth of cut, actually RPM and feed per minute are automatically entered for you. And depth of cut is pretty much how far you want the tool to plunge into the board. For drill bits, you want to go clear through the board, which will be about 62 mils or beyond. But you don't want to go too far where the drill bit goes into the machine. So 62 mils is the thickness of the copper plus a 59 mil substrate plus another piece of copper on the bottom. So you need to go a little bit beyond that depth in order to drill into the board. So now that I have my drill bits in here, I'm going to go OK and run the drill file. But actually, before I do that, take a note of this board here. So we have a lot of different cutouts here. So what I'm going to do is I'm going to try to position the board right at this location here, and hopefully we'll be able to mill out the circuit around there. So in the software, the orientation of the actual board is, like on the machine, is kind of rotated 90 degrees. So the position that I was pointing to here actually shows up on the computer in this area around here. So I'm going to move my complete circuit in all the layers simultaneously to that area. So I'm going to view all, or edit all layers, and let's see. So actually, I'm going to check one thing, make sure that I have the right layers. Okay, so one problem that I just saw is that my top and bottom layers don't line up. This is great because you can see how to register the top and bottom layers. So I'm going to edit all layers, and notice that we have a couple layers here in this screen. Okay, so I'm going to select all the layers, information that was not aligned with the rest of the board, and move that onto the board. So just going to click and drag, get a little closer so I can I'll line things up. I'm going to line up the holes, the magenta holes with these outline holes. So I can get right on top. Zoom in a little bit closer, make sure the drills are going right through. The centers. And there we go. So now I'm just going to hide all layers and just show you the top and bottom layers. So here's the top layer in blue. And I'm going to show the bottom layer in cyan. So you can see that the blue top and bottom layers line up. And let's see the drill holes. And the drill holes also line up with the holes. Okay. Now at this point, I'm going to move this board onto a safe area on the circuit board that we previously talked about. Okay, I'm going to move this board to the bottom around here. And then in order for the machine to accurately gauge depth where the material height is based on position, I'm going to have to use a feature called contact by touch. And let's see, this one's not. Okay. So what I'm going to do is up here, there's a menu for tools. I'm going to go contact by touch and set target area. Then I'm just going to drag to a section that's really close to the board. Just box it in. And here we go. We have our contact by touch target. So what the actual tool head is going to do is going to move over to the target area, lower down, press your foot and the drill bit, and figure out the material height for that particular tool. Now I'm going to, let's see. So now that that's all done, I'm going to look at the drill, hide all the layers and just look at the drill. So you see like there's about maybe 10 holes that are big and 2 small little holes. So let's run the drill layer and see what happens. Remember the mill, then run layer, and then the drill file. Right now it's expecting a 10 mil drill bit, 18 mil drill bit, and 42 mil drill bit. So I'm going to remove this the 10 mil drill bit because we don't have a tool for that. And theoretically, the 18 and 42 mil drill bits are all that we need to make the holes that are on the screen. So we'll go OK. The machine will start doing the same. So the first thing it's going to do is it's going to look up its tool table, and if it finds the drill bit for 42 or 18 mils, it's going to go to that position, pick up the tool, and then start drilling with it. If it was not able to find the tool, what it will do is ask you to put in the tool yourself. So my hand's on the red button here. It's ready to turn off the machine if it's killing itself.